Hello again, it's Mark here, and in this video we'll discuss various PV system components and types. Probably the most important component of a PV system is the individual cell. A single cell can range anywhere from 5, 6 to 10 inches. It can be square, oblong, or even circular. Cells are made of a semiconductive material that generates direct current or DC voltage when exposed to sunlight. When we take these cells and join them together, they create a string, sometimes called a stringer. We then join multiple stringers together to form the panel. There are usually 4 stringers in a complete solar panel, and we'll do all this together when we make our individual panels later on in the video series. The next item we're going to talk about is the array. The array, which is used to obtain a specific voltage and amperage, is a combination of 2 or more panels fastened to a mounting structure. Depending on the size of the system you want or need to develop, your array may consist of 3 or 4 panels, and some commercial applications may even have as many as 124 panels. Furthermore, depending on the need of an individual application, one could have 6 arrays with 24 panels per array. The next item we want to talk about is a charge controller. Now, there are many different brands of charge controllers that are available on the market, but they basically do the same thing. What a charge controller will do is prevent the battery bank from overcharging by automatically sending any excess power to a dump load. Some charge controllers also prevent the batteries from reaching a dangerously low charge level by stopping the supply of power to the DC load. So I can't stress enough that installing a charge controller is critical to maintaining batteries' performance in all but the simplest of PV systems. Another important item for a PV system is the batteries. Now, it's a device that stores DC power for later use. In a PV system, usually the batteries are used to store the energy that is created by the PV system during the daytime, so that the power can be used either at night or when it's cloudy. If you were to join multiple batteries together, then you would have a battery bank, which, as you can see from this picture here, a battery bank is nothing more than multiple batteries joined together to provide both the necessary voltage and amperage for a specific application. And in our other videos, when we talk about wiring systems up in series or parallel, you'll understand how these batteries are all wired together, because these batteries, as you can see in this battery bank, are in fact utilizing both series and parallel wiring to achieve the necessary voltage and amperage for this particular application. The next item is the inverter, which is an electrical device that converts DC power into alternating or AC current. This device is what enables us to utilize the DC power that we generated with our PV panel in our home. It takes the PV power, which is direct current, feeds it into the inverter, and provides us with AC power, which we'll utilize to drive whatever loads or devices we want to use. The other couple of items we want to quickly talk about are DC loads and AC loads. Basically, a load, how we refer to it, is just what the electricity is going to drive or to power. And here you can see that in the DC loads I have a light bulb and a fan, and then below in the AC loads we have a radio and a TV. Now, probably you've seen DC light bulbs in flashlights or other devices, but you can see AC light bulbs as well, and a fan can be an AC or a DC. You've probably seen DC radios that work on batteries, or radios on alternating current that you plug in a wall. And even though I listed the TV as an AC load, there are, in fact, DC-powered TVs. For example, when my kids were smaller, we had a DC-powered TV that we'd put in the van whenever we took trips. So I'm saying all this to say this. Basically, a load is nothing more than a device that uses the power we generate. Our ultimate goal is to build a PV panel or panels that produce DC power that we can transform into the AC power for our home. Now, there are different types of PV systems, and I'm going to try to touch on a few basic types, from the very simple to the more complex. And this is not to say that you have to have one or the other. This is just to give you a range of how flexible PV systems can be. PV systems can be configured in many different ways. You can have a day-use system, which is only used during the daytime. Residential systems will charge the batteries during the daytime to operate devices during the nighttime. Large industrial or commercial systems will probably have an inverter to convert the DC power to AC power, whereas a PV system in a small cabin, like in the hunting cabin or in the mountains somewhere, may provide power for only DC appliances and will not need an inverter. I have to tell you that most, if not all, large industrial commercial systems will most certainly have an inverter. Most PV systems are linked to the local utility grid, while others may operate independently. And chances are that if you're looking at this and you're on a computer, then you probably live in a house which is connected on the electric grid, and you're looking at a way to offset or utilize power from a PV system to help reduce what you're paying for the electricity. But then again, you may have a hunting cabin for which you want to create power to use certain devices while you're there. So let's talk about different types of PV systems. Okay, a day-use system is the simplest and least expensive PV system. It's called a day-use system because they're designed for day use only. They're usually wired directly to the DC load or appliances with no device or storage battery. Some examples of this kind of system might be a DC-powered water pump that may be used to fill a storage tank for the local livestock, or you might see an operation of fans during the daytime or blowers. Or if you're out in the country, it's not uncommon to see gate openers for which power is provided by a solar or PV panel. Okay, the next system we're going to talk about is an off-grid system. Now, an off-grid system basically is completely self-sufficient. In order to operate the appliances at night or during cloudy weather, the PV system must include a means for storing electrical energy. A deep cycle battery is the most common means by which power generated by the PV system is stored to be used for later. As you can see here, it's a pretty straightforward system in which the PV panel or panels are generating DC power that goes to your charge controller, because as we noted earlier, you definitely want to protect your battery so that they don't get over or undercharged, continuing to the storage battery, and from there drives your DC loads. The next system we'll talk about is an off-grid system with a generator. This is like the previous one, which is completely off-grid. However, you'll notice that this one is a little more elaborate. We have the same PV panel, and just as before, the energy goes to a charge controller, which in turn forwards it to the storage battery or battery bank, depending on the size of your system. From the storage battery, the power goes to the inverter. Now, an inverter, as we talked about earlier, is the device that actually takes the DC or direct current and converts it to AC or alternating current, so we can use it in our home. So the inverter passes voltage up to the AC electric panel. And this is usually the panel that you would find in your garage or maybe in the back bedroom or even somewhere else. From the electric panel, branch circuits run throughout your house, and devices connected to those circuits would be the AC loads. What makes this system a little bit unique, often called a hybrid system, is that it also has a generator, as you can notice down here on the right bottom corner. Now a generator, and this generator, which you can find in various Home Depots, could be gas or diesel powered, generates DC power and, like the PV system, runs power through the inverter. But essentially, it's just another means by which you can have power. So if it were cloudy or at nighttime and you didn't have enough energy storage in your batteries, you'd fire up the generator and you'd be able to operate the individual devices that you wanted to use. Now this next system is an on-grid system. However, this particular system here does not have any battery backup. Once again, you have the PV panel, but since we don't have any batteries, we don't need the charge controller, but we definitely have to have the inverter because we're still going to take our DC power converted to AC and pass that on to the AC electric panel. However, if you look over here on the far right, we have the AC power lines. Now, where you live, the power lines may be above you or they may be underground, but that's what your electric utility service supplies you with. The AC power lines come through the electric meter on the side of your house, and it goes to your electric panel. So in this particular case, your PV system may be adding to or subsidizing what you're getting from the utility company, and that would help you offset your electrical costs. However, this grid system does not have a battery backup. Now the next slide we're looking at here does have a battery backup. Okay, so you have the same configuration basically. However, since we've installed the battery into this system, then once again we have to have the charge controller. All this is showing is that photovoltaic systems are so flexible that they can be used by themselves or with your local utility system to produce power that you can be able to consume in your household. Here's a visualization of a solar power system connected to the local grid. Basically, this here is a graphical representation of what we're trying to convey right here. It's pretty straightforward. It comes in from the utility service into the service of the house, and here you see a meter, and you have your inverter, which is tied directly to panels. You'll notice that in this particular graphic that there are no batteries. Therefore, you do not see a charge controller. You just have the energy from the panels going directly to the inverter, and it goes to the AC electric panel, and then it passes voltage on to the devices in the house. In summary, we talked about the major components of the photovoltaic or PV system. We talked about the PV cells and how we connect them to get a stringer. We combine the stringers together to create a panel, and then we take the panels and add those together to make arrays. We've also talked about the charge controller and the inverter. A charge controller to protect the batteries, and the inverter to take the DC power and convert it to AC power. We talked about the different types of PV systems: the day use, which is simply for the day use only; the off-grid system, which is completely separate and self-sufficient; the hybrid system, which is off the grid but it has a generator to produce backup power; and the on-grid, when you're tied into your local utility. So once again, all of us here at Earth for Energy would like to thank you for spending your time with us. We hope you found this informative, and I'll speak to you again soon. Bye for now.